ICT teacher of Nazarbayev Technical School of Taraz.
Please watch this video and tell me how it is connected to the topic of our lesson.
In a world where databases are present everywhere, where energy consumption is recorded in a database, where all financial information is stored in a database, as well as the number and duration of all phone calls, where inventories, transport information, and even entertainment bookings all require a database, where almost all websites are powered by a database, when getting the right information at the right time is critical for many businesses. One language is used to access all databases, and this language is SQL. You'd better know it.
Yes, you are right. Topic of our lesson: Structured Query Language or SQL. Learning objective: create, evaluate, and improve search queries that use multiply criteria and relational operators to find specific information. Lesson objectives: understand what is SQL and how it's used, understand what the syntax commands do, and be able to write SQL commands. Success criteria: be able to use the select, update, insert, delete commands. Be able to create queries in SQL. First questions. How do you think? What is SQL? Before we learn about SQL, let's understand what is data. In simple words, data can be facts related to any object in consideration. For example, your name, age, height, weight, etc. are some data related to you. Picture, image, file, PDF, etc. can also be considered data. Now, what is database? We already know what data is, but this data could be random. A database is a systematic collection of data. Since the data in a database is organized, it makes data management easy. What is Database Management System or DBMS? Database Management System is a collection of programs which enables its users to access database, manipulate data, and help in representation of data. It also helps control access to the database by various users. And now, let's watch video with examples.
An online telephone directory would definitely use database management system to store data pertaining to people, phone numbers, and other contact details. Your electricity service provider is obviously using a DBMS to manage billing, client-related issues, to handle fault data. Let's consider the Facebook. It needs to store, manipulate, and present data related to members, their friends, member activities, messages, advertisements, and a lot more. We can provide countless numbers of examples for usage of DBMS. Database management systems are not a new concept, and as such had been first implemented in the 1960s. Charles Bachman's Integrated Data Store, or IDS, is said to be the first DBMS in history. With time, database technologies evolved a lot, while usage and expected functionalities of databases have been increased immensely. Types of DBMS. Let's see how the DBMS family evolved with time. The following diagram shows the evolution of DBMS categories. There are 4 major types of DBMS. Let's look into them in detail. Hierarchical. This type of DBMS employs the parent-child relationship of storing data. This type of DBMS is rarely used nowadays. Its structure is like a tree with nodes representing records and branches representing fields. The Windows registry used in Windows XP is an example of a hierarchical database. Configuration settings are stored as tree structures with nodes. Network DBMS. This type of DBMS supports many-to-many relationships. This usually results in complex database structures. RDM Server is an example of a database management system that implements the network model. Relational DBMS. This type of DBMS defines database relationships in forms of tables, also known as relations. Unlike the network DBMS, our DBMS does not support many-to-many relationships. Relational DBMS usually have predefined data types that they can support. This is the most popular DBMS type in the market. Examples of relational database management systems include MySQL, Oracle, and Microsoft SQL Server. Object-oriented relational DBMS. This type supports storage of new data types. The data to be stored is in the form of objects. The objects to be stored in the database have attributes, for example, gender or age, and methods that define what to do with the data. PostgreSQL is an example of object-oriented relational DBMS. So what is SQL? Structured Query Language, SQL, pronounced as SQL or sometimes as SQL, is actually the standard language for dealing with relational databases. SQL can be effectively used to insert, search, update, and delete database records. That doesn't mean SQL cannot do things beyond that. In fact, it helps in optimizing and maintenance of databases and much more. Relational databases like MySQL, Oracle, MS SQL, Sybase, etc. use SQL. SQL syntaxes used in these databases are almost similar, except the fact that some databases use different syntaxes and even proprietary SQL syntaxes. An example of an SQL statement: select star from members where age is greater than 30. DBMS stands for Database Management System. We have 4 major types of DBMSs called hierarchical, network, relational, and object-oriented. The most widely used DBMS is the relational model that saves data in table formats. It uses SQL as the standard query language. SQL is the standard language used to query a database. The database approach has many advantages when it comes to storing data compared to the traditional flat file-based systems.
SQL stands for Structured Query Language. Allows you to work with the database. This language, which is the ANSI standard. SQL allows you to query the database, to extract data from the database, to insert new records in the database, to delete records from the database, and SQL allows you to update records in the database. SQL is easy to learn. SQL statements are divided into operators of data definition, or DDL, and operators of data manipulation, or DML. First operator of data definition is the create. You can create a database object, database itself, tables, views, user, and so on. Alter operators modifies the object, and drop operator deletes an object. Operators of data manipulation: select, insert, update, and delete. Select operator selects the data that meet certain conditions. Insert operator adds new data. Update modifies existing data, and delete deletes the data. Let's see first operators. It's the select. Select field name from table name where condition. Where select defines the field that contains the necessary data. From specific the tables that contain the field specified in the select. And where is the specific the condition of selection fields which must comply with all the records included in the results. For example, select star from customers. Output all fields and records the customers table because we select star. Star is the output all fields. Next example, select customer name and country from customers. In this example, you can see that this operator shows records customer name, country fields from customers table. Because we write select customer name and country, it's field's name, and from customers is the table name. Select customer name city from customers where city equal Berlin. This operator show records customer name city fields from customers table where the city field value is equal to the word Berlin. Go to this link and perform the task 1, 2, 5, 8, 12. Show your answers for teacher. We continue practicing simple SQL queries on a single table. This tutorial is concerned with the table of Nobel Prize winner. You can see this table, Nobel, and three fields, year, subject, and winner. Exercise. Using the select statement, first, change the query shown so that it displays Nobel Prize for 1950. Write a result, submit the SQL. Correct answer. Show who won in 1962 prize for literature. We change year 62 and subject. Submit the SQL. Correct answer. Winner is John Steinbeck. And next is this task. Show all details, year, subject, winner of the literature prize winners from 1980 and 1989, inclusive. Let's check your answers. We write our field names. From Nobel, it's our table name, and selection condition where subject equal literature, and year submit the SQL. answers. Perfect. Next task. Show the physics winner for 1980 together with the chemistry winners for 1984. Check your answers. We write year, subject, winner, from Nobel table, and write our selection condition. Subject equal physics, and year for 1980 together we write year equal 1980 or subject chemistry we can copy this code and paste here. Subject equal chemistry and year 1984. Submit SQL. Correct answer. Last task. Find all details of the prize found by Eugene O'Neill. Check your answer. Selection condition. Winner equal O'Neill. We can copy this name and paste in our query. Submit SQL. Correct answers. Second operator. To change the values in one or more columns of the table, use update statement. Update table name, set field equal new value where selection condition. For example, update customer, set contact name equal student, city equal Taras, where customer ID equal 2. After update statements, record fields customer name and city in customers table has changed. You can see at this example how records to customer ID 4 changed to student and Taras. Now let's check how did you get to the point. Go to this link and update London to Berlin for customer ID 4. Perform the task. Show your answers for teacher. We have table customers in fields customer ID, customer name, contact name, address, city, postal code and country. And we can update London to Berlin to customer ID equal 4. Let's see write SQL statement. Update customers, set city equal Berlin where customer ID equal 4. Run SQL and you have made change to the database row effect. Let's see our table customers and you can see and the customer ID 4 city changed to Berlin. Next operator insert. To add records to the table, use the insert statement. Insert into table name values. You can see in table name you write all fields name, and in values you write all new values. For example, insert into customers, customer name, contact name, address, city, postal code and country, values, student, Anwar Samatov, Satpayev 2, Taras, 000000, Kazakhstan. After the insert into proposals, at the end of the table, create a new record with the given values. Then you can see that customer name, contact name, address, city, postal code and country, its field name, and new values is the student and Anwar Samatov, Satpayev 2, Taras 60 and Kazakhstan. Now let's check how did you get to the point. Go to this link and insert values Bala, Askar Nagai, Abayev 1, Taras and Kazakhstan. Let's check your SQL statement. Insert into customers, customer name, contact name, address, city, postal code, country, new values. Run SQL. Result: you have made change to the database. Let's check our table. Open customers table and you can see we add new row. To delete rows from a table, use a delete statement. Delete from table name where selection condition. For example, delete from customers where customer ID equal 3. You can see after the proposal delete from, the third record with values completely delete. Let's check how did you get to the point. Go to this link and delete row where customer ID equal 12. Perform the task. Show your answers for the teacher. Let's delete row where customer ID equal 12. We can write our SQL statements. Let's check your SQL statements. Delete from customers where customer ID equal 12. Customers is the table name and customer ID equal 12. Run SQL. Let's check our table. Open customers table and you can see that customer ID 12 row delete. And now let's practice. We have table, actor info, and 4 fields: actor ID, first name, last name, total films. The first task. Solve this task using insert query. Insert into actor info values. First, Leonardo DiCaprio 35. Second, Matt Damon 61. Third, Jack Nicholson 75. And fourth, Mark Wahlberg 34. And now you can see how our students coped with this task.
We have one table which is called actor info table, and in this table 4 fields: actor ID, first name, last name, and total films. The first query is insert into Leonardo DiCaprio. First is Leonardo DiCaprio, and we have to put insert all information about this actor. The actor ID first name is Leonardo, Last name is DiCaprio, and total films is 35. And we have to fill all the table like that. Second is Matt Damon. The total films is 61. And we should put this one here. The next is Jack Nicholson, actor the third. Jack is first name, Nicholson is last name, and the total film is 75. And the last one is Mark Wahlberg. Number of and total films is 37. So the name of the table is actor info table, and the result of our first query is something like that.
See how our students coped with this task.
So our next query is select star from actor info. So we have actor info table, and when we see the star, it means that we have to select every field from this table. It means that the query result will be like that, because we have to select every field.
Third task. Select actor ID total films from actor info. Actor ID and total films its fields, and actor info its table name. Please see how our students coped with this task.
Our next query is select actor ID and total films from actor info. It means that we have to select only two fields, is actor ID and total films. It means that we have to remove another two fields, first and last name. We have to remove them from table actor info, and we will show only these two fields, and the query result will be like that.
Next task. Update query. You can solve this task using update query. Update actor info, set total films equal 36, where actor ID equal 1. Solve this task using delete query. Delete from actor info where total films over than 70.
Our next query is delete from actor info where total films is more than 70. It means that we have to find the actors which has the total films more than 70 and just remove them. It means we have only one actor, it has 75, it is more than 70, that is why we just remove this, and our query result will be this table.
Last task. You can solve this task using delete query. Delete from actor info.
Our next query is delete from actor info. It means that we have to delete all data which which is saved in this table. It means that we just remove all data, and the result will be empty table.
And now let's have reflection today's lesson. Did you learn useful information for yourself? Where did you have difficulties? What would like to explore in the next lesson? Please give answer for these questions. This is used links. Thank you for your attention. Goodbye.